Hi friends, today we are going to see about OSPF areas. So let's let's try to get a few numbers in order to find out like how we divide into areas. So let's just try to remember some numbers. I'm giving like 427913612. So just keep in your mind those numbers. If you need to remember those numbers again, it's 4279113 and 612. So it is like what we are trying to bring over here is like to remember how we are going to remember a lot of things. So it takes a lot of energy for us to remember some stuffs. When we include most stuffs, we it takes time for and a lot of mental energy to remember a lot of stuffs. And same thing is what happens for a router. So if a router is getting LSAs, the link state advertisements from other routers, and if one router gets updates, if router one is getting an update from router two, and router two is saying, "Oh yeah, I got." So if router one has four interfaces, and it's going to say with the IP networks, and it's going to say with those four interfaces with the IP networks to router two, saying that this is what I'm having. So each and every time it should get updated. So the here the cost for those the individual interfaces, we have to remember all of that. If we have like 100 or 1,000 of routers, that doesn't scale very well, because then we have a router like ourselves that has to have all those LSAs remembered and put into a linked state database. To solve that problem, OSPF can be taken as a whole and can be put into separate domains or chunks. So, like to describe with this, we can describe a concept where it's beneficial to understand a bigger picture. We're going to return to focus on a single area OSPF network as we continue to configure, verify, and troubleshoot it. So, let to enforce the concept. So, we will see like how to get these routers. We'll get like one more layer. So, all right, like so. I'm trying in this picture. There is some balls we have written like we are going to consider those balls as router 1, router 2, router 3, router 4, router 5, 6, 7, router 8, 9, 10, 11, 12, and 13. So with the LSAs and link state advertisements, let's imagine that every router has at least four interfaces or more that are currently up, and they are connected to IP networks. So that means that every router is sending advertisements about its own interfaces and their status, and it says their own IP networks and how they are connected to. If it is a router 1 2 3, so accordingly like they send their updates. So 1 2 3 4 5 6 7 8, like I'm saying like around 13 routers here. So if a router number 9 is going to get the information from router 1 2 and 3, everybody else will get all the interfaces and their connections and all their networks. So that's a lot to keep track of in the link state database. So if these are all in a single area in OSPF, that's what would happen. So every router would have information about the link state advertisements from every other router in the network, and it can be a lot of overhead. So one option with larger networks with OSPF is we can divide our OSPF routers into subsections or domains or groupings. So it might look like so that's what is called as an area. We call it as if we take area 0.0.0, like let's take it as area 0, and it's just a number, so we label it. So for an area, a grouping of networks in a certain area, all routers that really belong to an area will be grouped in an area. It's really their networks they are connected to. If this was just area 0, the four interfaces could belong to only to area 0. So maybe like three interfaces in our 2 belong to an area 0. So when we think of areas, think of a collection of networks as opposed to a single router, because we could have a situation like this where we have another area. Let's take this area like area 2, and perhaps router 2 has a connection right there. So let's call this area 1. So we're taking 1 2 3 4 5 6 and 7 and area 1, and 8 9 10 11 12 13 as area 2. So the point is, when we think about areas or grouping of a network, it's not just one network, it's a grouping of networks. So those three networks belong to area 0, and one of the interface belong to area 1. We could divide or group our networks, and we could call this as area 2 and area T. So the benefit is that when this router 1 is advertising LSAs, the LSA does not have to make it through the entire network. So the LSA can stay in the area, and then we can have the other advertisements in the second area. But the what we are trying to bring here is like every single router have a personal knowledge of their LSAs from every single other network and every other single router in the entire OSPF infrastructure. So the concept of breaking up the OSPF into smaller areas, so that we are decreasing the workload on each of the routers which are trying to calculate the shortest path of any given destination network. So if you take 9, instead of having all the details about everything up here in area 0, it is simply like router 5 that's acting as a gateway. If you take router 5, it's acting as a gateway or route that will forward back to anywhere outside of that area to another area. At the same time, router 9 has the workload has been released, because no longer has to process or keep track of the link states being advertised by router 3 or router 1. So the reason we introduced this concept is like when we start telling a router this network and that network and this network and add them to OSPF, we need also to tell in which area we're going to add those networks to. So we are going to add all our interfaces, all our directly connected networks into area 0, and then later we are taking a look how a multi-area OSPF works. So we are just concentrating on a single area OSPF, like how it works, to verify it, and how to troubleshoot it in OSPF, and what the knowledge of we require for the link state advertisement and the LSDBs, the link state database, how much amount of the link state database when we make all routers to bring in like into connected networks, what is the LSDB, the amount of memory that the LSDB would consume. That's the reason that we are separate into areas as like area 0, area 1 and area 2, and we communicate them between those areas. Hope this video is useful to you. Subscribe, and like I've written some 2 books as well, like I've added to this video. You can have a look on it. Cheers guys.